Hey there guys, welcome to the 2.4 note, solving multi-step equations with variables on two sides. Now this is more or less the part 2 notes of the previous notes. In that last set of notes, we still were dealing with multi-step equations, but you either had left on just the left side or x on just the right side. In this case, you're going to have x on both the left side and the right side of the equation. Now lucky for us, we still use the same 5 steps we used in the previous note. We still start with distribution if we see parentheses. Combine like terms if there are like terms on the same side of the equal sign. So that's either a coefficient with a coefficient or a constant with a constant. We still get variables on one side. Now, last set of notes, you either had x on just the left side or just the right side. In this case, since you're going to have it on both the left and the right side, this is where you're going to say, okay, the right side is just for my x's, so they all have to be on the right, or the left side is just for my x's, so they all have to be on the left. Same thing with the constants. We have to choose a side for our constants, and then finally we're going to solve for our variable. So you might get it to 2x equals 8, or negative 5x equals 10. So we begin with our first example, negative 2x minus 15 equals 2x minus 7. Now in this case we cannot use step 1 because we cannot distribute. There are no parentheses. So we'll move on to step 2, combining like terms. Remember, we combine like terms on the same side. So I look on the left side of the equal sign, negative 2x minus 15. Now you might say, oh, I can combine negative 2 and negative 15. Wrong. Remember that negative 2 is touching a variable, which makes this negative 2 a coefficient. Conversely, that negative 15 does not have a variable, so it is a constant. Since they are not the same, that negative 2 has a variable, it's a coefficient. That negative 15 does not have a variable, it's a constant. They are not considered like terms, they cannot combine. Same thing with the 2x and the minus 7. One has a variable, one does not, so they cannot combine. So we also skip 2 and we move on to step 3. We're getting variables on one side of the equal sign. This time it does matter, because I see that I have an x on the left, and I see I have an x on the right. So it doesn't matter which side you move it to. You can move them both to the left or both to the right. Now, as you get better at these, you might be able to say, oh, it's better to move it to the right side, because that means the inverse operation is going to be plus 2x, which avoids negatives, versus moving it to the left side, which is going to be minus 2x, which is going to introduce negatives into your problem. It doesn't really matter. So if you get better at it, you can choose what side to move it on, but for the rest of these notes, I'm always going to move it to the left side just for consistency. The right side also works. So with deciding that I want all my variables on the left side, I need to move this 2x on the right to the left. And remember, I move things around from one side of the equal sign to the other with inverse operations. So the opposite of a positive 2x is a negative 2x. So my 2x's cancel out, which leaves me with negative 4x minus 15 equals negative 7. Now this looks like the problems from our last set of notes. So remember, since I now claim, hey, the left side is my variable side, it wants to kick out this negative 15. So it says, hey, go over to your side, go over to the right. So I need to use inverse operations to get it to the right. This time, since I have a negative 15, the opposite is a positive 15. So I cancel it out, and I'm left with negative 4x equals negative 7 plus 15 is the same thing as 15 minus 7, which leaves you with 8. Once again, this might be intuitive. You might know what negative 4 times what number gives you positive 8, but we're just going to follow our steps. So we're on step 5 now, solve for the variable. Negative 4x, that coefficient, negative 4, is being multiplied to these x. So instead of adding 4x to both sides, I'm going to divide by negative 4. And your last step is usually going to be dividing. I say usually, it is not always. So x is negative 2, which makes sense. Negative 4 times negative 2 will give you positive 8, since negative times negative is positive. So we have our next example. Same idea, so we're still going to get into the practice of it. I want to claim the left side as my variable side, so I'm going to kick out this variable to go to the left. And I do so by doing inverse operations. And I always make sure when I do my negative 5 to put it underneath the term that it can combine with, the other number with the x. That's going to give me negative 2x plus 14, these cancel it out, equals 10. And this is old hat. I know where to go from here. Hey, I'm kicking you out constant because we claimed the left for the variables. So minus 14, negative 2x equals negative 4. Because 10 minus 14 is negative 4. You took away more than you have, so you're in the negatives. And then solve for the variable, usually with division. So x equals positive 2 this time, which makes sense. Negative 2 times positive 2 will give you negative 4. So those are just basic variables on both sides. Now they won't always look like that. Sometimes they'll look like this, especially as you start getting into star level solving equation problems, where they involve all 5 steps. Now this one doesn't have all 5 steps. As you can notice, there's no parentheses. So we can't do step 1. We cannot distribute. But we can do step 2, which is combining like terms. You'll hear my dogs in the background. So, on the left side, I only have a 7x, but that's not the only thing that can combine. I can combine the 8 with the 5, but I can also combine them with the negative 7. They're all constant, so they can all combine together. Now 8 plus 5 is 13. 13 minus 7 is 6. So I'm left with 7x plus 6. Now notice I didn't say minus 8 or plus 7 plus 7. If they're on the same side, you just combine them. It's combining like terms. So no canceling, no inverse operations, just add them and subtract them together. So just 8 plus 5 minus 7. And I haven't done anything to the numbers on the right, so I bring them down. Now this example looks like this example. And that's all you're really doing is simplifying until you get into something you're familiar with. Like I said, doesn't matter if you move x's to the left or right, but for all these examples, I'm always going to move my x to the left. Which means if I want to move this guy to the left, we're going to do inverse operations. 7x minus 6x is just 1x, plus 6 equals 6. Since I claimed the left for the x's, that means that I need to kick out this constant 6 by doing inverse operations. So I'm going to subtract 6 from both sides, and that's going to leave me with 1x equals 0, because 6 minus 6 is 0. Now you can stop here. 1x is the same thing as just writing x by itself, but you technically have solved the problem of x equals 0. Or you can just divide by 1 on both sides. If you forget that 1x is the same thing as x by itself, that's fine. You still get the same answer. So we move on to the next problem. In this case, as the title kind of tells us, we can distribute. So we're going to distribute that negative 2. So that's our first step. Since we're going to distribute on the right, we are not going to do anything on the left. So we're going to do negative 2x times x, which is negative 2x, negative 2 times 10, which is negative 20. Bring down everything on the left. In this case, once again, moving everything to the left, as far as x's go. Don't do minus 2x. This time this x is negative, so I'm going to add 2x to both sides to cancel that negative 2x, and that is going to give us 8x. We need to get rid of this plus 12 because the left side is dedicated just to my x's, so I'm going to use inverse operations and subtract 12 from both sides. Be careful, one of the most often made mistakes from students is sign errors. This is negative 20 minus 12, so it's going to get more negative. It's going to get negative 32. A lot of students will forget their negative and just do 20 minus 12 and get 8, which is small calculation errors, so be careful there. And then our final step is usually division, so dividing by the coefficient of x. In this case, it was 8. So we get x equals negative 4, because positive divided by negative is negative. And then once again, just a general reminder, if they are on the same side, you're going to combine like terms. If they're on opposite sides, you're going to use inverse operations. Now we have some special cases. We have special case 1 and special case 2. In special case 1, let's see what happens. Let me not spoil it. So there's no distribution, there's no parentheses, but on the right side I can see, hey, I can probably combine things because there's more than 2 terms. So let's see what we can combine. There's only one x, so there's nothing I can combine with this x, but I have a constant 13, a constant negative 3, and a constant negative 2. So all of these can combine. 13 minus 3 is 10, 10 minus 2 is 8. So I have x plus 8 equals x plus 8. Huh. Strange. But, okay, let's continue. To get rid of this x, I'm going to subtract x, so I can move it to the other side. Oh, x minus x. That also cancels out. Okay, strange. Equals 8. Huh. Notice how you completely canceled out your x's. There's no x's left. All you're left with is 8 equals 8. And if you do minus 8 from both sides, you get 0 equals 0. This is special case number 1. If all your x's cancel out, and you're only left with constants, such as 8 equals 8, or 5 equals 5, or 1,000 equals 1,000, negative 1,000 equals negative 1,000, this is a case of infinite solutions. That is to say, no matter what x you put in here, it will always give you a true statement. Which makes sense. If all my constants add up to be 8, my x's are going to be the same. So even if I put 0, it's going to be 0 plus 8, which is the same thing as 0 plus 8. If I decide x is negative 2 plus 8, well, this is also going to give you negative 2 plus 8. So this is infinite solutions. Let me erase that so you can see it. Infinite solutions. So that it only happens if it gives you a true statement, such as 8 equals 8. Now special case number 2, let's see what happens here. This time on the right side I can combine my x's. I have a 6x and a negative 2x, and they're on the same side of the equal sign. They're both on the right side. So I just combine, I just do the operation 6x minus 2x, which is 4x. Bring everything else down, plus 5, 4x minus 7. Get the variable on the left side, so my inverse operation is minus 4. Ooh, 4x minus 4x. Huh. Cancel that again, but this time, this is not a true statement. Negative 7 does not equal 5. So this time, I have a false statement. If you have a false statement, there are no solutions. No matter what you put in for x, it will never give you a true statement. Because remember, the reason we're getting x is when we get this x and plug it back into the equation, it should give us a true statement. It should give us something like 2 equals 2. So in this case, every x will give us a true statement. In this case, no x will give us a true statement. And in these 4 cases, only one x will give us a true statement. So only negative 2 in this case, or only positive 2 in this case. So those are your 3 cases. One solution, infinite solutions, or no solutions. These 2 at the bottom are very rare, but we did want to discuss them. Now, similar to previous notes videos, this is where we're going to do it in class, just to check to see if you can do it on your own. So I suggest pausing the video, and then checking to see if you can do it. If you can't, you may want to sign up for tutoring. So, assuming you did pause the video, I'm going to go through solving it. The first example is just a regular 2-step equation, so just to check to see if you can do a 2-step. So, first step, move my x. It's a negative x, so I'm going to add x to both sides. And I'm going to get 13, negative 5x, remember x by itself is really 1. Negative 5x plus 1x is negative 4x equals 1. Move the constant to the other side. And that's, oops, kind of already did it in my head. So 13, which leaves you with negative 4x equals negative 12. And we're going to divide by our coefficient. Ta-da! X equals 3 is what you should have gotten. This one is a two-step with distribution. So you should know that you first start with distribution. So 2 times 3 is 6. 2 times negative x is negative 2x. First up is move my x to the left side by doing inverse operations. Opposite of 2x, or negative 2x is positive 2x, or plus 2x. And you end up with 16 plus 10x equals 6. And then, hey, we claimed the left side for my x, so move this 16. By subtracting 16, we get, that cancels out, 10x equals negative 10, because 6 minus 16 is negative 10. Divide by the coefficient of x. X equals negative 1. 2 more examples. So this one is 2 steps with combining like terms. And in this case, be careful. A lot of students will say, oh, 8x and 4x. This is a negative 8x. So be careful there. Negative 8x plus 4x is negative 4x. And then I can bring everything down. So remember, it's negative 4x because negative 8x plus 4. No canceling out. If they're on the same side, we said we combine like terms. And so, variable on the left side, and subtract 6x from both sides. Negative 4x minus 6x is negative 10x. Bring everything else down. Move the constant to the right, which gives you, wrong color. Negative 10x equals negative 10. Divide by my coefficient. X equals 1. This time positive 1, because negative divided by negative is positive. This problem, you might say, ooh, Miss Fuentes, that looks difficult. This is how they're going to look on the star. They get this difficult on the star. So make sure you can get up to this level of a problem. So you start off with the first one, which is distribution. In fact, there's distribution on both sides. Hopefully you know what 4 times 12 is. If not, that's okay. You can work it out either by using 14 or 12 times 4 like this, or using other tricks you've learned in class. So 48, 4 times negative 1 is negative 4. Don't forget to distribute to both terms. Negative 12x. Now be careful here. When I'm going to distribute, I'm going to distribute this negative 4. So not just a 4, a negative 4. Negative 4 times 1 is negative 4. Negative 4 times 5x is negative 20x. Step 2, which is combine like terms. Negative 12x, negative 20x are both coefficients. So I can combine those. This side isn't going to change, so I'm just going to bring it down. That's going to be negative 32x minus 4. Move my variable to the other side. So that cancels out, and that leaves you with 80. 80x minus 4 equals negative 4. Kick the constant to the other side using inverse operations. And that gives you 80x equals 0. Because negative 4 plus 4 is 0. Well, anything times 0 is 0. Similarly, anything... I might not have enough space to type this. Divide by 80, divide by the coefficient. X equals 0. 0 divided by anything is 0. Same thing as 0 times anything is 0. Great, fantastic. If you have any questions, feel free to sign up for tutoring. Otherwise, get started on your practice. Have a nice day.